is Wednesday. So we are going to carry on with our learning objective for the week, which is multiplying fractions by integers. We now know what integers mean. We now know how to multiply fractions by integers. So we are going to start with 4 questions for a warm-up. Now, these 4 questions were on your home learning task sheet today. They were 3/4 times 9, 1/3 times 8, 7/5 times 5, and 6/10 times 6. So I'm going to go through the answers to those first 4 questions to see how well you've got on with those. So if you haven't done those yet, pause the video, pause it, answer the questions, then press play and see if you've got the answers right. I'm about to go through the first 4 questions. Make sure you have answered them already. Don't cheat. Have a go. Okie dokie. So you should have 4 answers already to these 4 questions. I'm just going to go through the answers really quickly. 3/4 times 9. 3/4 multiplied by 9. You could say it's 9 lots of 3/4. You could say it's 3/4 add 3/4 add 3/4 9 times. The first thing I want you to remember, denominator stays the same. We are still dealing with quarters. And then we have 3/4 9 times. We have 9 lots of 3, which is 27. So your answer should be 27/4. If that's all you've written, that is correct. If you have had a go at turning that into a mixed number, well done. How many 4s go into 27? 27 divided by 4 is 6 whole with 1/4 remaining. That is also the correct answer. And for those of you who are enjoying the decimal challenge, the answer is 6.25. Okay, next one, 1/3 times 8. Our denominator stays the same. We have 1/3 8 times, which means we have 1 times 8, which is 8. So we have the answer of 8/3. That is correct. If you have extended that further, well done. We have 8 divided by 3. 3, 6, which is 2, and there's 2/3 left over. And the decimal equivalent is 2.66 recurring. Okay, 7/5 times or multiply by the integer of 5. Denominator stays the same. We have 7/5 5 times. 7 times 5 is 35. To turn that into a mixed number, we need to do 35 divided by 5, which is 7. There is no decimal equivalent except 7.0. Okay, and the last question is 6/10 times 6. Denominator stays the same. We are multiplying our numerator by our integer, which is 36. That, as a mixed number, is 3 whole and 6/10, which is 3.6 or 3.60. How did you get on? 1, 2, 3, or 4 out of 4? Hopefully you were able to have a go at those. So that was our warm-up. We're now going to move on to our next task. Right, so your next question was, what is 3/15 multiplied by 4? This was shown in an image using circles. So if you can refer back to that, then it will show you 4 circles, because that's our integer. And in each circle, there were 15 segments and 3 shaded in. And the question was, how many 15ths were shaded in? So the answer was, say it, can't hear you, shout it out, what was it? The answer was 12/15. Now, if you wrote that down, that is perfectly correct, and you're getting the hang of this really well, so well done. If you can, I want you to simplify this fraction here. Now, simplifying fractions means you are writing it in its simplest form. Can you think of a number that you can divide 12 and 15 by? Can you think of a times table that has 12 and 15 as its multiples? Well done. 3. You can divide both of these numbers by 3. So if you wrote 12/15, you are absolutely right. This is an extension. This is Miss Harris trying to challenge you. We are seeing if we can simplify this fraction. 12 divided by 3, 4. 15 divided by 3 is 5. So the another answer that you could give is 4/5. These fractions What's that word where two fractions are the same amount? Equivalent. Well done. So these fractions are equivalent, and those of you who want to try and convert that into a decimal, pause this video now and have a little think. And when you're ready, shout it out. It's 0.80. Or 0.8, sorry, or 0.80. My mistake. It's not 0.80, Miss Harris. 0.8 or 0.80. And who thinks they could turn that into percentage? 80%. Well done. So there you go. You can now go and ask your adults at home. Say to your adults, okay, parents, adults, carers, grandparents maybe, older siblings, what is 12/15 as a percentage? Go and see if they can work it out. Ask them, say, what is 12/15 as a percentage? See if they can get it right. Little challenge for you. Your next question showed this image, and it was asking what the calculation showed. So for this one, you need to look at how many parts your whole has been divided into. So we can count 1, 2, 3, 4, 5, 6, 7. So our denominator is 7. How many has been shaded in each whole rectangle? 1, 2 parts. So this rectangle shows 2/7. This rectangle shows 2/7. And this rectangle shows 2/7. Now, what is the calculation showing? It's shown that this is repeated 3 times. So you could say we have this calculation, which is repeated addition. You have 2/7, add 2/7, add 2/7. But we are multiplying fractions by integers this week. So we are going to write that it shows 2/7 multiplied by 3. That is the calculation that I hope you reached today. And then I'd like you to try and answer that question. If you haven't done it already, do it now or pause the video, because we'll want you to try and work as independently as you possibly can. The answer is 6/7. Okay, because if I was to take these two and colour them in on this rectangle instead, and if I was to take these two and colour these 2 parts in instead, I still have the same number of parts shaded, but this time I've shaded them all on the same rectangle. And you can count that I have shaded in 6/7. So that was the answer we were looking for. The next question said, Mr. Monroe thinks this shows 3/9 times 4. Do you agree or do you disagree? And please explain why or why not. So I want you to have a little think about this one and use the image on your daily home learning task, which is a lot clearer than my drawing. And I'm really sorry my rectangles are not the same shape. They should be consistent. Now let's have a look at this one. This shows 3/9. I'm just going to write that down. 3 are shaded. There are 9 pieces altogether. This one shows 3/9. This one shows 4/9. Okay, so what I'd like you to do is pause the video now and see if you can write down an answer that says something like, now this is where you put agree or disagree with Mr. Monroe, because. Now you can either do this verbally using your words, or you can write it down as a sentence. And I want you to try and explain. So do you agree or do you disagree with the fact that this shows 3/9 times 4? Pause the video, have a go, and then press play when you're ready. Okay, if you are coming back, I would hope that you have said, I disagree with Mr. Monroe. Now, I don't advise you do this very often, but I'm sure Mr. Munro really wouldn't have got this question wrong in real life. So this time we are going to disagree with Mr. Munro, because that is not 3/9 times 4. Because now one possible answer that you could write for this is 3/9 times 4 is 12/9. Okay, 3 times 4 is 12. Our denominator stays the same. Now 12/9 is the same as 1 whole, so that's 9/9, and 3 left over. Okay, that would mean we have 12/9 coloured in. Now let's see, do we have 12/9 coloured in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So one thing you could write is, I disagree with Mr. Munro, because 3/9 times 4 equals 12/9. And this diagram shows 10/9. That's one possible answer that you could write. Another possible answer that you could write is that if it's timesing by 4, if I write it down over here, if the question is requiring us to multiply by 4, then we should really have 4 rectangles, each showing 3/9 shaded in. That is another answer you could write. Or you could say that 3/9 times 4 equals 12/9, which is 1 and 3/9. Now, if we were to transfer these 4 shaded rectangles to here, 1, 2, 3, and 4, and if we were to shade these 2 to here, we would actually have 1 whole rectangle and 1/9. And that is not equivalent to the correct answer. So well done if you disagreed and you spotted it wasn't right, but you should also be able to explain why it's not right. Okay, and there's lots of different ways you can do that, and hopefully you've had a similar answer to one of the examples I have given you. Okay guys, I am back. So your next task was to show what 1/6 times 5 could look like. Now I've got 4 different ways here, all of which are correct. The first way you could show what 1/6 times 5 could look like is you could draw a rectangle. You could divide that rectangle into 6 equal parts, and you could colour in 1, 2, 3, 4, 5 of those sixths. So the answer is 5/6, and you could show that by drawing something like this. Or another way is you could draw 5 rectangles all split into sixths, and you could colour in 1/6 on each rectangle. So we've got 1/6 here, and we've done that 5 times because we're multiplying by 5. If you've shown something like this, that is also correct. That is also showing 1/6 times 5 is 5/6. You could also do that on a circle. You could split a circle into sixths, and you could colour in 5 of those pieces. You could also show me using repeated addition. We're not dealing with addition today, but it's a good way of showing that you recognise that this is the same as this. So there are some answers that are all correct. If you've done it a different way, you can always email us a photo to see if you're right. But that was one of the ideas. Any of these is what we were looking for. Right, this one was a little bit more tricky, so I'm going to be super impressed if you get this one right. Remember, ideally, I want you to be watching this after you've had a go. So I want you to have a go at answering the question first, and then watch this video to see if you got it right. So if you haven't answered this question yet, just put me on pause and then press play when you're ready. The next question was 2/6 multiplied by 3. So there's different ways that you can show this. You could show this using repeated addition to show that you are adding 2/6 3 times. You could show in a circle which has been divided into sixths, and you could colour in 2/6 and then do that 3 times. So that's 1, 2, and then 3 times. Oh look, the whole circle has been shaded, which means I have coloured in 6 sixths. So that is our answer. Denominator stays the same. 2 sixths multiplied by 3 is 6 sixths. You could show this in a rectangle. I've gone for horizontal lines this time. You could colour in 2 sixths and then do that. That's 1. This would be 2. And this would be the third time. So we could colour in 2 sixths again. That's twice. And then colour in 2 sixths again. And that is 6 sixths. Another way of writing 6 sixths is, well done, 1 whole. Another way you could show this is by drawing 3 different rectangles or squares or circles and dividing them into sixths and colouring 2 sixths on each shape. So this is actually the same as colouring in all the sixths on one shape. So this shows that you have coloured in 2 sixths and you have done that on 3 different shapes. So there are some different ways that you could show the answer. But if you got 6 sixths or 1, or as a percentage, what is 1 whole as a percentage? 100%. Well done, keep going. Well done guys for getting this far. I hope that you have been able to access some of that learning today. Last question. Would you rather have 9/15 times 4 of my chocolate? Or would you rather have 7/15, which is a smaller amount, but 6 lots? So, you're very lucky because normally I never share my chocolate with anyone. But today you have an opportunity to share a fraction of this chocolate. Now you can either go for the 9/15 times 4 option, which means you get a larger amount 4 times, or 7/15 times 6, which means you get a lesser amount, but you get 6 lots of that rather than 4. So what I'm going to need you to do to answer this question is you need to do 9/15 times 4 as one calculation, 7/15 times 6 as a separate calculation, and then see which is the greatest answer. And then I want you to go onto the WordPress website and see if you are right, because I'm not going to tell you the answer because I'm really busy eating as much chocolate as I can before you get the answer right.